Okay, now a rational function is a function that can be written as the quotient of two polynomial functions, p of x and q of x. So you can have a function in the numerator divided by a function in the denominator. Now for example number 3, we want to solve an applied problem involving a rational function. The question states that a large mixing tank currently contains 100 gallons of water into which 5 pounds of sugar have been mixed. A tap will open, pouring 10 gallons per minute of water into the tank. At the same time, sugar is poured into the tank at a rate of 1 pound per minute. We want to find the concentration pounds per gallon of sugar in the tank after 12 minutes. Is that a greater concentration than at the beginning? The solution. So let t be the number of minutes since the tap opened. Since the water increases at 10 gallons per minute and the sugar increases at 1 pound per minute, these are constant changes. In this case, constant rates of change. This tells us the amount of water in the tank is changing linearly, as is the amount of sugar in the tank. We can write an equation independently for each. So for the water, we would call that W of t, which is equal to 100 gallons of water, which is fixed, plus 10 gallons per minute, meaning t would be the minutes in gallons. Then we have sugar, which we're going to call S of t, which is going to equal 5, which we have 5 pounds of sugar, which is fixed, plus 1 pound per minute, so it's plus 1t, meaning t is the minutes in pounds. So the concentration C will be the ratio of pounds of sugar to the gallons of water. So the numerator has the sugar, the denominator is the gallons of water. So we have 5 plus t in the numerator divided by 100 plus 10t. And we're going to let C represent the concentration. Now, the concentration after 12 minutes is given by evaluating the function for when t is equal to 12. So now we're going to plug in 12 to be in for t. So we have 5 plus 12 divided by 100 plus 10 times 12, which gives us 17 pounds of sugar divided by 220 gallons of water. Now, at the beginning, the concentration is when t is equal to 0, because time would be 0. So t would be 0, so we have 5 plus 0 over 100 plus 10 times 0, which is 5 over 100, which reduces to 1 over 20. Now, since 17 over 220 is approximately 0.08, is greater than 1 over 20, which is equal to 0.05, the concentration is greater after 12 minutes than at the beginning.